So today we have some little wind, average 2.6 meters per second, and this big guy already rotates, but the small one doesn't. Because as I told you, the starting speed is at around 4 something, 4.1, 4.2 meters per second, but I have got the new hub and new blades, so let's try it. So here's the deal. These are the original blades from M3 wind turbine, SM3. And I basically used a default 3-blade hub and mounted on top of it the brush cutter plate. Brush cutter knife basically, so this is the 3 blades brush cutter, and drilled some holes just to make it tested. Just like please be advised, this thing is too thin, so I'm using this only for the test and don't advise to use it for like the original setup. So let's check what the hub actually is. So you see it's centered and the total length is 86 point something. So 1 meter 72 centimeters. That's roughly the diameter that I have. It's maybe just like 3 to 4 centimeters longer than the original SM3 hub, but I just didn't have the hub because the guy who borrowed me these blades, like he's using that original hub for his other blades that he's testing right now. So that's why I had to think of something to basically do the test. So yeah, let's go and get it mounted and see if the start will be so much better as the calculator says. Let me remind you, 4.1, 4.2 is the realistic start for my current 5-blade setup. And for this one, the expected startup is going to be at around 3.1, 3.2 meters per second. So let's go and check. So as you may see, no rotation and some rotation. That's the main difference since the wind is 3 something, 3.2, 3.4, fluctuates a bit. But yeah, let me put it on the brake, so just in case it doesn't start spinning, and let me change the hub so we will do the check. And here is the wind, even 3.8. So theoretically this one should have already started rotating, but as you remember we need 4.1, but this one is going good. So let's finally put it on brake. As you see, I've got 24 volts battery bank arrived based on this gel batteries. I didn't want to use the lithium PO4 for this case because this will be mounted in the non-heated area, and lithium does require some better temperatures than around 0, and for those gel guys it's absolutely nothing. They don't care about the temperatures that much. So let me put it on the brake. Okay, changing this PV off, and let me turn the wind off. This engages the brake on this controller. Remember, you see, brake highlights, and now all the load goes into the dump load via controller, and basically this is how it stops the turbine, so it will not rotate. It will be even hard for me to rotate by hand, actually. Any case, let's go and change the hub. So here you can see the difference. Not that big difference, right? So 1.72 meters for the 3-blade and 1.3 for the 5-blade. But the main difference is this thing. You see how this is bent? That's the main difference. It will allow very better start. As of these blades, they don't have this. It's way less. I mean, there is some bend, of course, yeah, but it's way less than on the 3 blades. So let me mount it and let's do the test. Okay, so here is the result. The result is pretty awesome. Wind speed is 3 something or below 3, and it keeps rotating. I mean, the drag is absolutely famous for these blades, and I'm more than happy with the result. I actually made the tail a little bit longer, just like screwed the piece of plate of steel plate to make it to be more stable on the wind. How to calculate it, how to make it properly, you will actually easily see. I will send you the link to the article how to calculate the tail length and what it should be. So let's go and check. I haven't put it on 24-volt systems. That's just like the next step. Still on 12 volts. And as you may see already on 3 meters per second, it has some production because, well, the battery drags the voltage down, and this one starts, this guy starts charging at 7 volts, and it slows the turbine down. So that's what actually happens. So my next step is definitely I'm screwing two batteries together to make the 24-volt system, and let's check how much better will it be. But even on this setup, you may see some better wattage already. So 8, 9, 4. Once it easily goes over 10 volts, it already has so much more watts produced. That's as easy as that. I mean, this setup has got quite a bunch of disadvantages, of course. But it's cheap and it allows to see how the thing will perform once mounted in somewhere atop like this. So just guys, I have ordered a couple of moss together with this Grapes house because like I did it myself some 5 or 6 years ago, just like very simply from the from the rebar, and yeah, it has to be replaced. So eventually the tower will be located over here, one of them, and the other one will be on that end, both 10 meters high, and it will be like the unified unique the same structure, nicely connected and very stiffly and sturdy. It will serve both things. It will serve for wind turbine, it will serve also for grapes. But yeah, as you may see, there is a lot of wobble because I haven't had a chance to actually balance it. I just needed to see how the start goes and if the thing actually can do something. So my next plan is SM3 wind turbine is already ordered and is going to come to me in about a month. And I will swap this head to the M3. And since the M3 has got a smaller generator, the smaller generator will be applied to this turbine body, and taken off now 5-blader hub will be put back on. So that's actually the plan, and this is how I'm going to do this. And I hope these two turbines will be good enough to basically be mounted on the towers over here and over here. One more thing. So once we are here, I will let you know that we are going to also add another wind turbine like this, but the bigger one. Somewhere over here, I'll put the tower. One more thing to add. So today we have the southern wind, and well, actually I was telling you already that this solar station probably is shading a little bit this wind turbine. However, as you may see, the rotation is quite good. I don't know what the wattage currently is, but anyways, I will show you later what do we have. Because the wind is going to pick up to 4 to 5 meters per second during the day. But tomorrow, the wind will be blowing from over there. So as you may see, there is nothing, no obstructions, and it will be facing the clean wind. So tomorrow, the test will be the most exact and the most correct. So let's wait until tomorrow. I will not release this video until there is a full information about everything. So yeah, that's basically it for today. I will show you later, because later today the wind is going to pick up a little bit, so we will see how much better the production actually is. But as I may see, the rotation is getting quite higher, so this may actually be the good sign. So the wind has picked up as promised. Rotations are getting sometimes way better. Let's go and check if the production has improved a bit. Yeah, 9 watts and more. Just bear in mind that it still is wind shaded, not having a clean wind. It still is way too low, and it still is not balanced because this is not the factory hub. It's like my my hands-made hub, which is not really well balanced. That's the difference. So far, that's the best for today, 20-30 watts with the voltage, as you may see. So 1.7 meter 3-blader seems to be doing very good. And I'm quite happy with the results. You have seen if it goes way over 20 volts, the wattage actually gets so much better. But let us test two more things. So one, I'll put it back on 12-volt battery and see if there is any difference on this exact same windwheel. And then I will put back the 5-blader, 1.3 meter India, and let's check if that would make any difference on 24 volts. Because on 12 we know what's going on. So step number one, switching back to 12, then switching the blades to the 5 blades, and then back battery to the 24 volts, and let's see what the difference is. So here's the thing. The wind is about like how it was between 4 and 5. It fluctuates a bit. Still 3-blader, 1.7 meter, 12-volt battery. Let's see if the output is better. No, not really, not really. The reason for this is because, well, as I said, the battery is dragging it down a little bit. It starts charging, it starts taking some current from 5 volts already. It doesn't allow to spin it too much. However, once the voltage gets higher than 10, the wattage gets so much better. It's 12, 8, 7, you see? That's a difference. Let's check if the 5-blader will be doing any better. I don't think so. I think on 5-blader we will see 2 watts max. But let's check, why not? So, here goes the 5-blader. The wind is still around 5. It barely rotates. Let's see what's the output. On 12-volt system still. You see, it's around 1 watt and 4 volts only. So it doesn't get up too much because it can't pick any rotation, any decent rotation too. Oh, the wind died. Or maybe it's turned back, it's turned around. Who knows? No, it's just not enough wind for it to turn. You see? Below 4, not enough to turn. That's the major difference. Okay. Right now, 3.9. It stopped. Ha ha ha. You know what? If 5.1 and it doesn't turn, even being wind shaded, I don't care. I will take it off and put the 3-blader back on. Like, no, it's not for this generator. This 5-blade hub doesn't work with it. Absolutely. So yeah, I'll put this 3-blader back with this nice dragging element on the blade. Yeah, putting it back on. Wind under 5, and the difference is massive. You know? I mean, of course, it's not balanced. Of course, it's not a factory hub on these blades, but man, it works. So now I know what to do next. Let's wait for a clean wind tomorrow and see how it goes. Good morning of the next day. So guys, here's the difference. Once it has a clean wind, as you may see, it already is blowing from a different direction. And the wind is not that heavy, like 3.6 only. gusting a little bit, sometimes up to 4. And let's go and check what the results are, how it actually goes. It sits much more stable. Very often goes way above 20 volts. And if it goes over 20 volts, the wattage increases absolutely nicely. You see? Let's just wait a little bit until the wind picks up and it gets up to 4, 5 range. The results will be so much better. Just like also bear in mind that, as I told you, the cables are very thin. That's true, I know. The height is not good enough, I know. But this is the test that allows me to understand the capabilities. And of course, while mounting it on a normal and standard working place, all those things will be fixed and adjusted. Because this is the test setup, I understand this. There you go, only like maybe 15 minutes later. The wind has picked up. You see the rotation. And let's go and check. Here's the difference. You see? 40, 50, 60, 70. I specifically switched to the amps because I don't want to see the voltage. I know the voltage is quite going very much higher than 30 even, which is good. I want to see the amps. How actually does this thing work with handling the charge? And it handles really well. It goes down with the amps if the wind dies. So it does allow the turbine to keep rotation. It handles it really well, you see? Well, the wind fluctuates, you know, the gust happens and it blows heavier, the gust dies, and then the standard wind is left. But I've seen today even over 100. If I will catch it, I'll get it to you. Oh, right now it's 70, you see, 80. 70, 80. That's a very good result for a test setup like this. Oh man, I guess it may even go in breaks at some point. I'm not aware where the breaking point of this thing is, not sure yet. But maybe we will see it today. What I can definitely tell, yes, the upgrade was worth it. The generator is absolutely so much better. Because at that original one, I was able to see only 34 watts peak on real wind. 34. Here and today we won't have like really heavy wind, and I've already seen 100 plus. Nice plus. So the upgrade was definitely worth it. I just only have to think how to make the hub more stable because, well, it's my manufactured one. And I will eventually not be using it for much longer than today's test, but because I want to keep the system stable. Who knows, maybe I will need to unload something. Like this controller is actually, it's a good thing that it has the load. You can connect it directly, you can make it go out like for any bulb, any lighting decorations for night, for day, whatever. The setups that are such that you can basically use it for different periods of the day. The option of on off of this exact load, not the dump load. Dump load is separate, don't mix it. I mean just like normal standard load, like nothing specific. And in my case, because I have the batteries almost full, at a certain point I might have to connect the second resistor to this load to basically unload it and to get out the charge. Or maybe I have this GTI Who knows? Maybe I can use it to drain the batteries and to put it back to the grid. So who knows? I'll try it as well, probably today. Yeah, but that's it. That's basically it. If I will see something really over 100, I will let you know. So yes, as I told you, this grid tie inverter basically works with draining the batteries and putting it back through the socket into the network and compensates my usage. So currently it drains it very slowly because it's set so. But yeah, it's good enough because the wind died eventually. It's around 3 meters per second and we don't see any big wattage right now. But anyways, it's good point to see that this thing will be safe, that there will be no overcharge for the batteries and that there will be no overload for the wind turbine. It will not be too stressed too much being on brakes for long. So that's basically it. And this will be the step for you to understand how the system will be evolved. So multiple controllers plus wind turbines, because one wind turbine can go into one controller. That's it. You cannot put two wind turbines into one controller. And this is the pairs wind turbine plus controller will go into 24-volt battery pack. This is not the only batteries that I have. I have like two more. They'll be later added in parallel once mounted on the stable and fully mounted system. And then this kind of inverter will drain them up and put it onto the somewhere in the network, but not like this case, because currently I just only need to like slowly drain the batteries out. But eventually it will go into the GAN port of the inverter that I have. Basically the same place where now currently my big wind turbine goes into. So this one, yeah, if you remember, this one gets into the, let me go quickly and show you, just so you remember how it's everything set. And that will be it for today. Okay, so here is the big guy, the big inverter, the hybrid one. It has its own battery pack. These are lithium, so they cannot be stored anywhere outside. They don't like cold temperatures. But it has the GAN port, and on it I can supply any grid tie inverter. Here is another one. Currently, as you may see, the wind died way too much, so there is no production. But yeah, once it blows, it blows. Rotation doesn't mean production. I hope you understand that. Once the wind picks up, like this, just a little, there is some production. Yeah, so like you can mount 2, 3, 4, 5, as many as you wish. No, not as many as you wish. The only limit for this thing is you cannot input into the GAN port more than there is a capacity for so-called bypass. Let me find you. Where is that thing? Oh, it probably doesn't say here. Standalone utility. Not sure if it's located somewhere over here. But if you will check the manuals for this kind of inverter, you will find out that 50 amps is the limitation for the current that can get into the GAN port. So yeah, that's the thing that I have to consider, and you know, I can mount maybe 4 to 5 more turbines easily without any troubles. That's one of the ways how to connect solar with wind. Why not? You can also unload them directly to the batteries, but I just don't want to do this because these batteries are they rather stay on its own controller, original one. I would want it to be like that, and for the other purposes I will use that gel batteries I showed you earlier. So that's it for today. Thanks for watching, and yeah, oh, it was a long video. Great thanks for those who stayed until the end. You know, I hope it was interesting enough. Thanks.